Hello, class, and welcome to Environmental Biology, Biology 120 here at Rio Hondo College. These will be lecture videos based on the chapters that we'll go over in the modules. This chapter is on chapter 1, and my lecture videos will be anywhere between 15 and 30 minutes long. So they might be a little bit shorter, but that is to encourage you to watch the entire thing and to gain study tips and access to other materials that I post in Canvas. So here we have kind of an introduction to environmental science and talking a little bit about sustainability. We'll talk a little bit about human impacts on the environment, population, resources, sustainability, what exactly is environmental science, and then addressing environmental problems. So first, when we think about why it's important to even learn this material, food is kind of our first look as the lens for environmental study. For an example, a chicken sandwich contains and requires all of these ingredients in order to manufacture, transport, energy to treat the wastes and packaging. And our choices matter and will affect the environment. We're going past simply the just recycling stage of things, but looking at kind of how each daily choice can potentially impact the environment. And that's kind of the goal of this course, is to give you a little bit broader understanding of environmental science. So what do you think about when you make your food choices? I probably think about what is the most tasty. But the next thing you do make a food choice, think about all of the energy and ingredients that were required to bring that food to your table or desk where you're eating. And then what will happen to the packaging or waste material that's generated when you are done eating. The environment, also known as Earth, here we have kind of a beautiful look at the Earth from space. Earth is well suited for life. Water occupies over 3/4 of our planet. It has a very habitable temperature, moderate sunlight. We have atmosphere, which provides oxygen and carbon dioxide. We have soil with essential minerals for plants. And then we look at human impacts on the environment or population. So modern humans appeared so many years ago in Africa and then quickly expanded. And now the human population, at this point, this textbook was a 9th or 10th edition, but at this point, our human population is roughly 7.8 billion. It's growing exponentially, which means, for many years of the Earth's history, Earth's population was growing kind of, just very slowly. And then we have kind of the Black Death, other plagues where the population dipped. And then, due to this exponential growth that we see occurring really in the past 100 to 200 years, that was due mainly to the prevalence of vaccines, healthcare, sanitation, that really caused the Earth's population to really grow exponentially. And we are the most significant agent of environmental change. A little bit more about population. More than 1 in 4 people live in extreme poverty where they cannot meet the basic need for food, clothing, shelter, and health. And it's difficult to meet population needs without exploiting Earth's resources. Countries were differentiated based on wealth. So if we look at, there was a study done looking at the gap between the rich and poor. We differentiated the countries based on wealth, looking at highly developed countries that have complex industrial bases, low population growth, and high per capita incomes. For example, the US, Canada, and Japan. And we look at more or less developed countries as a more low level of industrialization, very high fertility rate, high infant mortality rate, and a low per capita income. Many of these countries, unfortunately, are in Africa. Others include Bangladesh, Mali, and then Ethiopia as an example. There's a rising income disparity between many of these countries. So we have a large gap between wealthy and poor citizens. And this differential gives less access, to electricity, cars, and modern medicine. An example of where this rising income disparity is growing is in China, India, Brazil, and Mexico. So when you have this big gap between the rich and the poor, that's when we run into problems. Population and resource use. So the essential resources for individual survival are actually pretty small, but a rapidly increasing population can quickly overwhelm or deplete, especially locally. And this can occur when the resource consumption can far outweigh the needs for survival. So, for example, affluent nations use a much larger proportion and can exhaust resources globally. Population and resource use movements in highly developed nations are changing the demand. So, for example, we have a tiny house movement going on where the houses are typically less than 1,000 square feet. And the types of natural resources. So let's look at types of natural resources. Very important topic. We have renewable and non-renewable natural resources. Renewable natural resources are ones that never run out. We have solar energy, energy from winds, tides, flowing water, fertile soil, clean air, fresh water, and other biological diversity like forests, food crops, and fishes. Whereas a non-renewable resource can run out. We have non-renewable resources in our metallic minerals like gold and tin, the non-metallic minerals in salt, phosphates, and stone, and then fossil fuels, which are non-renewable, coal, oil, and natural gas. Consumption of these resources, so humans use materials and energy, and people in those high developing countries are much larger consumers of these resources. The unsustainable consumption will occur when the level of a demand on a country's resources will damage or deplete the resource enough to reduce the quality of life for future generations. And this can be caused by overpopulation or overconsumption. The ecological footprint is the average amount of land, water, and ocean required to provide one person with all the resources they consume. So we have in Earth's productive land and water, we have 11.4 billion hectares. The amount that each person is allotted, we divide that productive land divided by the human population. You need about 1.8 hectares will be allotted for each person, but the current global ecological footprint of each person is about 2.7 hectares. So what this means is that each person realistically is using more resources than what the earth can provide. Obviously, that changes because some people will use more resources and some people will use less. But in general, if we divide the earth's productive land and water and divide it by each person, the current global footprint of each person is using more than what the earth can provide. So humans have a little bit of an ecological overshoot based on previous years. And again, this is different because some humans are much more ecologically savvy and recycle and use less of and make less of a earth footprint than others. But it's just a good reminder that our ecological footprints, we should try to make them as small as possible. So per capita ecological footprint, the US uses much as well as the total ecological footprint. The US is using so many resources and making much more of an impact based on consumption needs of the people compared to other countries. The IPAT model will measure three factors that affect the environmental impact, where total environmental impact, shown here by the uppercase I, is equal to the number of people times the affluence per person times the environmental effect of technologies, and that gives us the total environmental impact. Fuel efficient vehicles, we have average fuel economy has decreased, between 1988 and 2000, the miles per gallon has decreased widely due to, sport utility vehicle and this huge, popularity of larger cars using more fuel. Fuel efficient vehicles can help lower the impact, as well as efficient driving can lower the fuel impact. So in general, why do we want to become environmentally sustainable? Is to make sure that there are resources enough in the world for following generations to use. So we want to focus on sustainability, stabilizing human population, preventing pollution where possible, restoring degraded environments, using resources efficiently, protecting natural resources, educating on boys and girls, preventing and reducing waste, and then eradicating hunger and poverty. So the ability to meet current human need for natural resources without compromising the needs of future generations is what environmental sustainability is. This requires understanding of the effects of our actions on the earth, and then that earth's resources are not infinite. They will eventually wear out. And that's where we get to this environmental science. The tragedy of the commons was this idea kind of born from Gareth Hardin, where he tried to solve environmental problems and showed that it was a result between short-term welfare and long-term environmental stability, where we have a common pool of resources, and Garrett used common pasture land in medieval Europe to illustrate this struggle. Sustainable development, the systems concept, this is the idea where we have the economic development that meets the needs of the present generation without compromising future generations. And we call this sustainable development, where we take environmentally sound decisions, socially equitable decisions, and economically viable decisions, and they'll all lead to sustainable development. So environmental science then is this interdisciplinary study of human relationship with other organisms and the earth, specifically that has to do with ecology, the environment. Earth system and environmental science, the system is a set of components that interact and function as a whole. We have global Earth systems where we include the climate, atmosphere, land, coastal zones, and ocean in that. And then we have ecosystems, which is a natural system consisting of a community of organisms and its physical environment. Feedbacks, we talk about negative feedback, which is a change that triggers a response that will counteract or reverse the changed conditions. So for example, if we have population and food supply that are balanced, but if we increase the population and the food supply becomes inadequate, the population will decrease due to increased mortality. And that's an example of a negative feedback change. A positive feedback change is a change that will trigger a response that will intensify the changing condition. For example, polar and glacial ice melt, color change leading to more rapid melting. So if we have climate stability, but an increase of CO2 in our atmosphere, the climate will warm, this will melt the poles, and it will cause an increased absorption of solar heat, which will cause a positive feedback to continue this warming. The scientific method then is a very important way that scientists use to discover new material and test it and see how it can stand up with other questions. The scientific method starts by recognizing a problem or an unanswered question, and then developing a hypothesis to explain that problem. Then an experiment is designed to test the hypothesis. The results are analyzed, data is interpreted to reach conclusions to see if the hypothesis predicted the reality, in which case they keep testing to verify the hypothesis, or if the hypothesis was wrong, they reject or revise the hypothesis and start again. This eventually leads to new knowledge that can be shared with other scientists. New knowledge might result in new questions, so we start the process over again, or other scientists can test that hypothesis, often in ways different from the original experiment. When we're doing experiments, we have variables and controls. A variable is any factor that can influence a process, and the variable may be altered in an experiment to determine its effect on the outcome. A control is when the variable is not altered, and this allows for comparison between the tests of when we alter the variable and when we do not alter the variable. A theory then is an integrated explanation supported by a large body of observations and experiments. Then they are evaluated by peer reviews. The theory helps to simplify, clarify, and predict new relationships within the natural world. An absolute truth will never be possible in science because knowledge will always evolve as new evidence is found. So that's important to remember that, an absolute truth isn't possible in the world of science because we'll continue to have new theories that might evolve. Hypothesis and theories. So here let's talk about climate change. We have carbon dioxide and other gases from burning fossil fuels are affecting the climate. We're unable to test or run these large experiments globally, so we must acquire lots of data and adapt theories and understanding with new data. Many parts of climate theory are tested, so the rise in CO2 and how it could impact solar radiation. And then we have a 5-step approach, which represent an ideal approach. Reality is untidy, but often the public pushes for a solution. So 5 steps to addressing an environmental problem. We have a scientific assessment where scientists find higher than normal levels of bacteria, for example. We do a risk analysis problem. We educate the public and involve them. And then we might take a political action where we will support an elected official, which will develop a plan that support this process. Long-term evaluation is when, for example, the water quality is tested frequently to see if our hypothesis was correct. Assessing another environmental problem. So for example, let's talk about the case study of Lake Washington. We have a large, deep freshwater lake. In the 1940s, we had suburban sprawl, where you have 10 new sewage treatment plants, which are dumping treated effluent high in nutrients into the lake, causing an excessive growth of cyanobacteria in this freshwater lake. And the bacterial decomposition of cyanobacteria then depleted the oxygen in that lake. So what we have then is a scientific assessment done by the University of Washington, studied the problem, collected the data, and then informed the Pollution Control Commission that the commission concluded that these effluents added nutrients, particularly phosphorus, which caused a growth of cyanobacteria, decreased bacteria by depleting oxygen levels, and the low oxygen levels ultimately resulted in reduced fish and small invertebrates in that freshwater lake. And if the pollution stopped, the lake would recover. So the recovery plan is that there were a lot of political hurdles in passing a plan. Eventually, there was an accepted bill to try to treat the sewage and divert it into a trunk sewer rather than the lake. And eventually, it discharged it into the Puget Sound, where it would have less effect. And by 1975, 20, 30 years later, the lake was healthy, the water was clear. And today, they work to reduce waste generation in view of the greater population around the lake. So data shows the recovery plan working. We have lower levels of phosphorus and chlorophyll in the lake, and you can see how those levels are going down. So that's just an example of a case study in which you can use that idea of, political action, developing a problem and a solution to change the environmental impacts of our decisions. Enviro news. So at the end of every chapter, we have a little bit of news environment. You might have heard of our green roofs or eco roofs, where we have vegetation and soil on impervious roofs that act as a little mini ecosystem that helps to insulate buildings, reducing energy costs, filtering out pollutants from rainwater, reducing stormwater runoff into sewers, and providing a habitat for wildlife. And the largest individual green roof in the US at the point that this textbook was published was on the Ford Motor Company factory in Michigan. So that's a little bit of an introduction to chapter 1 to environmental science. We'll see you soon for chapter 3.